this tutorial I'll show you how to create a 2D sprite based game that uses the Unity NavMesh system to navigate around a map. As for now, there is no support for 2D sprites in the Unity NavMesh system because the system is purely based on mesh renderers. And as for now, all sprites are using sprite renderers to render to the screen, so the NavMesh system can't create a NavMesh that sprites are able to traverse. So how did I manage to create a sprite that navigates around a map if it's not supported at the moment? Well, I have actually made a 3D game underneath my 2D game, so the actual functionality lies underneath this in a 3D game, and the visual part is just my 2D sprites. We can take a look at it here in my hierarchy. As you can see, I have something called a 3D map object, and I have something called a 2D map object. The 2D map object contains a rock, my map, and the tree. So that's like my whole map here, and the tree and the rock. If I would disable these, you'll see that I have nothing else on the screen. The same goes for my sprite. I have a sprite here, which I can disable and can't see anything at the moment. Then I have my 3D map, which is actually the map that has the path in it. So if I would select all my items inside my 3D map and enable my mesh renderer, you'll be able to see that I have a whole map here that is based on 3D objects. All these objects are containing my navigation mesh. So if I click on my navigation button here, you'll see the blue pattern, which is the navigation mesh that my characters are able to traverse. The same goes for my sprite. Before I had my sprite here, which was my animated sprite I could walk around with. Underneath my animated sprite, I have my agent, which is actually just a cube that walks around my 3D mesh. So if we play our game again and click around, you'll see that it's just a cube navigating a 3D world. So what I'll show you in this tutorial is how to create all this from scratch, how to set up the camera, how to set up the 3D world, and how to put the 2D on top of all this 3D modeling so that we can navigate our world with a 2D character. I'll also show you how to code everything and how to make sure that the character is playing the right animations at the right time. So that's the intro, and let's get started. Let's get started setting up our project. When I created this project, I put Unity in 3D settings as default, and because of this I have to do a few things before we can get started with the project. First thing I need to do is to rotate my camera 90 degrees, and the reason I'm rotating it is because I want to view my sprites or my 3D models from top down. And if I wouldn't rotate my camera, I would have to rotate all my 3D models, and that would make some complications when we want to create our NavMesh. So instead of getting into all those problems, I've chosen to rotate my camera instead. One more thing we want to do to the camera is to change the projection from perspective to orthographic. When you go into orthographic, the camera is not able to see depth or perspective in it. If we would put it back in perspective, we would be able to see the depth and everything in the models, which we're not interested in this point, because the visual part of the game is a 2D game. So we rotate the camera to get the right angle on the objects, and we put it in orthographic so that we can see our 2D sprites normally. There is one thing: when we have rotated the camera 90 degrees, all our 2D sprites will have a wrong angle whenever we import them, which means we need to rotate all our 2D sprites 90 degrees. So now we are actually set up for starting importing our stuff. So the next thing I would do is to import all the sprites. All the sprites can be found in a link below the video. So I already have this this folder with all my sprites, and I have my map I should navigate, we have my character I want to navigate around, and we have 2 obstacles. All these things can just be imported by selecting them all and dragging them to the asset folder. I want to keep all things in order, so I'm going to create a new folder by right-clicking in my asset folder and selecting folder. This folder I'll call Sprites. Going to take all these sprites and drag them into the sprite folder. So now the project is set up and we are ready to start creating our game. Okay, so let's start creating our map. Before we create our map, I would like to put the scene in the right view, and to do that we need to click the axis navigator to view the camera from the back, so we see the same thing in the scene view as we do in our camera game view here. To do that, we click our camera and we can press F to get closer to it. Anyway, we need to use this axis navigator to get in the right angle, and if you can't see this navigator, it's probably because 2D is enabled, or sometimes it's also invisible in 3D mode. So if you press the 2D button here and let it go, then you should be able to see it here. Press the Y axis so you'll be able to see the camera from the top. So now we can see that our X axis is aligned here and Z is up. And now I'm actually seeing whatever I want to see from my camera. So now we can start pulling our sprites. But before we pull them in, we need to change the texture type from texture into a 2D sprite texture. So if we select all our sprites, click the texture type to Sprite 2D and UI. Whenever you have done that, just click the apply button. When the apply button is clicked, these textures has changed into 2D sprites, and we can now start pulling them into the scene to create our 2D game. First of all, we want to create our 3D world, but we need the 2D map to create our 3D world from. So we take the 2D map and drag it into our game. As you can see, it has the wrong angle, and that's what I discussed in the first part, that all these 2D sprites has to be rotated because we rotated our camera. So what you have to do is to click the map and rotate the X axis 90 degrees. When you've done that, you take the 2D map and drag it in front of your camera. As you can see, there are some parts of the sprite that is invisible, and we want our camera to have the right size so that we can see the whole sprite, and this can be done by clicking the main camera and changing the size. I'm not sure what size it has to be, so I'll just click on the size and drag it slowly to the right until I can see the edges of the map. Then I can drag it a little up here. Yeah, this should be fine for now. So now I should be able to see my whole 2D map. As you saw in the beginning of the tutorial, I had some different objects here that contained the 2D map and another one that contained the 3D map. So to create a little order here, I can click on the create button and create empty and rename this game object to 2D world. I also want one world for the 3D map, so I click again, create empty, press F2 to rename, and write 3D world. So now I have 2 empty game objects that both would contain 2D world and a 3D world. My map here is a 2D world, so I will take it and drag it to the 2D world part. Now we can start creating our 3D world on top of our 2D sprite, which is actually our traversable map. What I want to do is to create some 3D objects that cover these dirt walls, so that these dirt walls will not be traversable whenever our character moves around in this map. The way I'm going to do this is to take the 3D objects and place them on top of these dirt walls. It's going to be easier for us if we change the perspective a little here, so that we can't see the depth in the picture whenever we place the objects. Because whenever we want to place the objects, we want to be sure that they cover the sprite 100%. To make sure that we have the right perspective, you can click in the middle of this axis tool here, so that you can't see the depth anymore. And now we'll have the exact same view up here in our scene view as we do down here in our game view. To create a game object to cover these walls, we click Create, 3D Objects, and a cube. If your menu looks a little different than mine up here, it's because that you're not using the Unity beta version 4.6. If you're using the Unity stable version 4.5, you can do all this as well, but I'll be using this new rect tool here, which is new in the beta, to stretch this object around the third walls. If you use the 4.5 version, you can as well use this tool, which also stretches the objects. I'm going to use the rect tool here to stretch this cube around the third walls. First I'm going to zoom in a little so I can see the edges and place it in the middle of the wall. When I've done that, I'm going to stretch it to the edges of the wall so that it covers everything I can see, because I want to make this part non-traversable. This cube, I would like to be able to distinguish it from other objects, so I just click on it, press F2 and call it wall. Maybe I should do it without caps lock. There you go. So now this object is called wall. I want to place it on all the other walls, so I'm just going to duplicate it by right clicking on it, pressing duplicate, or selecting it and pressing Ctrl D. When I've done that, I can just place it around the map to cover all the third walls. In the middle I have a water path, and I don't want that to be traversable, but as you can see, there's a little part here that that makes up a stone bridge that my character should be able to path through. So I'll create this one consisting of two objects. So I'll just cover one side of the water like this, and then I'll duplicate it and place it on the other side of the water bridge. When I've done that, I will need to cover the top part here, so I can duplicate this wall, place it on top here, and drag it all the way to the edge, because I don't want any of this third wall to be traversable. There you go. So now I've created all my edges. So all these walls are part of my 3D world, and I want to select them and make them as child elements of my 3D world game object to make it easier for me to distinguish my objects. Yes. Now I want to create the ground, because I also need a 3D object as a ground so that my character can traverse it. I can do that by clicking Create and selecting 3D object and plane. My plane needs to fill out all the space again, so I just select my rect tool and drag it all the way to the edges. To make it easier to distinguish my walls from my ground, I can create another material so that my ground can get some color. So I can click on my asset folder, right click Create, select material, and write ground material. I can just select any color, let's take red, and I drag my material to my plane. And as you can see, I've created a model of the map that we have down here. My plane is also a part of the 3D world, so I'm just going to drag it to my 3D world object. Now we can start creating the mesh that our 2D and our 3D model can traverse. To do that, we need to have the navigation window open, and you can open that by clicking Window and finding the navigation plane, clicking that. As you can see, there is like some different tabs up here, and the first tab is the Object tab, which indicates that we need to tell this navigation which objects that is going to be part of the final path and final navigation mesh. This means that all floors, walls, doors, everything that has to be a part of the navigation mesh has to be added here. These objects can be added to the navigation mesh by selecting them and clicking the navigation static. When something is navigation static, it tells the navigation mesh that it's going to be part of the navigation mesh. When we have done that, we can select what kind of layer it has to be on. For example, there is some parts of the map we don't want to be able to traverse. For example, all our walls. To make them non-traversable, we click all of them and click not walkable. When something is not walkable, it's going to be calculated in the navigation mesh as a part of the mesh that you can't walk on. The plane is a little different because we need to be able to walk on it because it's going to be a ground. Actually, let's just rename our plane to ground by selecting the inspector, clicking F2 and writing ground. When we need to make our mesh, we can create it by clicking the bake button here. Bake is what we do whenever we create a mesh. If you click the bake tab up here, you can set up some different options for our navigation mesh. The radius is how big the radius around the object should be before it's traversable. The height is how high a thing should be for a character to pass under it. The max slope is how steep something should be before it's going to be a wall in the game, which means, for example, 45 degrees means that something that is less than 45 degrees is traversable, but something that is higher than 45 degrees is looked at as if it was a wall. Step height is how high something should be to be a step or a wall. So if something is higher than 0.4, it's calculated in as a wall, which you can't traverse. But if it's lower than 0.4 or equal to 0.4, then it's traversable and you can step over it. For now, let's try to click the bake button and see what happens. I need to save my scene before I bake this mesh, so I just save my scene and I write test scene. As you can see, there are some problems here that the mesh doesn't take up everything. So I guess my radius is a little too high. I'm going to change it to 0.2 and press bake again. And as you can see, my mesh fills out very, very smoothly here. And all this blue part is where my character is able to traverse now. Now that we have baked our nav mesh, we can add an agent that can traverse this nav mesh. And to do that, we just click on the 3D world object, right click on it, select 3D object and select cube. And this cube is going to be our 3D agent. So we just click inspector, press F2 and rename it to agent. Now that we have our agent, we need to place it in the right position. So we place it in the bottom left corner because that's where we want our character to start. Before our agent can traverse the mesh, we need to add a NavMesh agent component to it. And we do that by selecting the agent, clicking component, clicking navigation, and clicking NavMesh agent. This NavMesh agent has some different settings. The radius decides how big the agent's radius is. This means that if two agents meet, the bigger the radius, the bigger a circle the two agents will take around each other. The radius is only affecting how agents avoid each other. It has nothing to do with avoiding other obstacles like walls and boxes. Speed decides how fast the agent will move. Acceleration decides how fast the agent will accelerate from 0 to its maximum speed. Angular speed decides how fast the agent is able to take a turn. Stopping distance decides how far away from its target the agent will start slowing down. Auto traverse off mesh links is only used in Unity Pro, but it allows the agent to traverse from one mesh to another if the two meshes are not connected. Auto braking decides if the agent should start braking automatically whenever it reaches its target. If auto braking is off, then the agent will overshoot its target. Auto repath allows the agent to take another path if something is blocking its current path. Height sets the agent's height. Base offset creates an offset between the anchor point and the agent's 3D model. Obstacle avoidance allows you to set the quality of the avoidance. The higher the quality, the more precise is the avoidance. The lower the quality, the better is the performance. Avoidance priority, it allows you to set the agent's priority. So if you have more agents, you can prioritize some types of agents over others, so those agents will get through the pass first. Agents with lower values have the highest priority. NavMesh walkable tells your agent what kind of layers it's allowed to walk on. For now, just leave it on everything. Now we're ready to start creating our navigation system, because the agent with the NavMesh agent component and the NavMesh itself is going to take care of the pathfinding as long as we give it a target to move towards. So the next thing we have to do is to create a script that assigns a target to this agent. One more thing, before we start creating the script, we should move the 3D world so it's underneath the 2D world. Right now it's on top of the 2D world, and that's not what we want to. So let's select the 3D world and then just drag it under the 2D world like this. One more thing, because we just moved our 3D world, we have to rebake our NavMesh, because the NavMesh is now somewhere up here in the air, and we want it to be on the right plane where the 3D world is. So just select the 3D world, click navigation, and click the bake button again. As you might as well just disable the visual, the sprite renderer on the 2D world, because we don't need it at the moment. Okay, when you've done that, we can start creating our script. So down here in your asset folder, you can right click, create C# script, and call it agent script. When you have created the script, just double click on it to open it. Okay, so the first thing we have to do is to interact with the NavMesh agent component here. So we're going to make a variable that is going to hold this component so that we can assign a target to it. So the first thing I'm going to write is like private NavMesh agent and give the name agent. So now we have our variable. This script, this agent script here, is going to be attached to the agent game object. So the way we can access this NavMesh agent component is just by writing agent and then say get component NavMesh agent. So now we have grabbed the agent component from the game object it sits on, and now we can use this agent variable to access the component on the game object. Next thing we have to do is to assign a target to this agent component, and I want to assign the target at the position where I'm clicking in my game world. So the first thing I have to do is to check for mouse input. So if input.get mouse button down, button 0, which is the first mouse button. So if I click my mouse button, then we have to create a raycast, because what I want to do is to click somewhere here in my game world and make a raycast, and then the place that my mouse raycast hits is the new target that my cube or agent here will move towards. So I'm gonna create a ray, which is the raycast at my mouse position. I'm just gonna call it ray, and it's gonna be thrown at the camera main.screen point to ray, because I want to translate my world coordinates of my mouse position into on-screen coordinates. Then I'm going to write input.mouse position. So what this does is that it takes the mouse position and translates it into my screen coordinates by using the main camera, and then it saves the info in array. Then I need a raycast hit, because a raycast hit can contain all the info about the raycast, what is the hit point of the raycast, and so on, and what game object did I hit. So now I have the two variables I need to create my raycast. So if physics.raycast, I'm going to use the raycast method here, and it wants some different parameters. See, there's one where it wants like array, and array, which I made up here, and array cast hit info, which I made right here. So I'm gonna give it the array I made, and out array cast hit info. It's called hit. Then we can make another if statement and say if this hit info after we have giving it the info through the raycast method here, hit.collider.tag, if that tag is ground. So if we clicked on the ground somewhere, well, then we want to assign a new destination or a new target to our agent here, which is our NavMesh agent. So agent.set destination, hit.point, which is the point that we hit. So what we just did is that we assigned the mouse button 1 to create a raycast. When we create a raycast and we hit the ground, then we're gonna set the agent's destination to that point where we hit with the raycast, if we hit a game object with the tag ground. The reason that I'm not using 2D raycast here is because I'm only raycasting towards the 3D world. I'm not using a raycast on the 2D sprite. That is only the visual part. Okay, so when you're done this, just save your script. I can give you an overview of it if you want to see the whole thing here. And then you go back into Unity. In Unity, we have to assign the ground tag to our ground object here. As you saw before inside our script, we were looking for the ground tag whenever we use the raycast somewhere on the ground. So select your ground object here, go to the tag tab, press add, write ground, and then go back to your ground object and select the ground tag. So what I've done here is to assign the tag, but we need to do one more thing because we just wrote a script, and this script should be attached to the agent object. So just take it and drag it onto the agent object here. So it's a component on the new agent object. So this should actually work now. If we press anywhere here on our red part here, then our object should be able to traverse to that position. So if I click play and click somewhere, as you can see, then the agent runs around here and navigates to the position I clicked with the shortest path it can find. So now we have created all our 3D world part. So now we need to create the visual part, which is the sprite part on top of this. Let me just stop this. To create the 2D part of the game, we need to handle our sprites first. So let's just start with hiding all our 3D world by selecting all the game objects and selecting the mesh renderer so we can't see it anymore. Then going to the map, which is our 2D world, and selecting sprite renderer. So now we can see our 2D world. Next thing we need to do is to handle the sprite sheet with the professor. So what you can do is that you can select it, and then we need to slice all these individual images into images that we can use in our animations. Right now you should select the sprite multiple if it's not selected already, because that indicates that we're going to handle a sprite sheet and not a single sprite, as you see here. So select multiple and open the sprite editor. Inside the sprite editor you can see all the sprites that are attached to the sprite sheet, and what we want to do is to slice them so that we have every single image individually, so we can use them to create an animation. So if you click the slice button, you can select some different options here. What I want to do is to select the grid option here. If you select automatic, it will automatically slice the slides after the alpha values, but we are interested in having slices that has the same size. And I know how big this sprite sheet is, so if I select the grid button, you can see that the pixel size is set for 64 times 64, and that's exactly the size that we need here for this tutorial. So select the grid size, grid type, and select the slice button. And as you can see, it sliced all our images into individual images. You don't need to do any more than just clicking the apply button then. If we go back into our Unity editor, you can see that all the images has been sliced into individual images here, and these are the images that we're going to use for our animations. The first thing is that we want to test that everything works, so let's just click the images that makes him walk to the right, just select these. It's from 27 until 35, so click on the top one and hold shift down and click on the lowest one, so we select all of them. We want to create an animation from these, so we just select them and drag them into the scene view. When you do that, it will ask you to create a new animation. You can see I already have an animation called Walk East, but you don't have it, so just write Walk East as the animation name and click Save. When you have done that, 2 items are created in your folder. An item called Walk East animation and an animation controller. This controller is going to be the controller that makes sure that we use the right animations when we walk to the left, right, up, down and such. So it's going to control all our animations. So if you click F2 on it and rename it to Sprite controller. As we look in our game window here, or in our scene view, you can see that in the hierarchy we have the Professor Walk object that we just added, and we also want to rename it to something that makes it easier for us to distinguish it from other objects. So click on that and press F2 and call it Sprite. As you can see that this sprite has this animator component on it, and that's what all animatable sprite has. The animator component has a sprite controller, or like an animation controller, which is the sprite controller we just made. That means that this sprite controller we have here controls the animations on the sprite object. To make it easier, we'll just make a new folder here in our asset folder called animations. And what I'm going to do is I'm going to take my Walk East animation and my sprite controller and move them into the animations folder, so that I have them there. And what did I do? I forgot to get the Walk East with me. Okay, I'm going to try again. There we go. And the sprite needs to be moved back out. There you go. Okay, so what I just did with some clumsiness is that I just moved all my animation things into the animations folder here. Yep. So now that we have the sprite controller and Walk East animation here, we can start manipulating our animations. If we click our sprite and go to Window and go to Animator, you'll see that there is already an orange Walk East animation here. And the reason that this one is orange is because that the Walk East animation is the default animation for this sprite controller. Later, when we create the rest of the animations, we need to drag them into this window and make transitions from Walk East to Walk West, North and South, for example. For now, just look at this as the controller of all the animations. So that means if we would play our game now, it would play this Walk East animation as the default animation. So let's drag our sprite a little around so that we can see where it is in our game. So if we put it in front of the camera here and rotate it 90 degrees, because we already rotated our camera, and that means that we need to rotate every single sprite. If you do that, you should be able to see the sprite in your game window view. If you can't see the sprite, it might be because it has like a wrong placement here compared to your camera, so you might move it up and down along the Z-axis. Sorry, not the Z-axis, of course, the Y-axis. Let's see here. We're going to place him here, and just place him in the left corner here around the cube's position, and then you can take your rect tool and then scale him up so he has like a decent size so you can see him on the screen. When you've done that, we need to create a script that makes him follow the cube around. So now we have a single sprite, and we can actually play our game and see that he's actually animated now, because he's attached, he has this sprite controller attached to him, and the sprite controller has the walk east animation as the default animation. If you click on the sprite, you can see that the walk east animation is played over and over again. Okay, so let's start creating the script that makes him follow the cube around the world. If we go to our scripts folder, which I don't have yet right now, let's just create a folder called scripts and move the agent script in there and create a new script called Sprite script. Attach the script to the sprite object right away, so we don't forget to do that, and then double click on the script to open it. Okay, so we need a target for the sprite to follow around, and to do that we just make a public transform called target, and this transform is going to be the cube's transform, so that we can follow it around the game world. Next thing we need to do is to make sure that the the sprite moves around with the cube. So I'm going to make a method here called late update, and this is the method that we're gonna use to update the sprite's position. The reason that I'm using late update and not using update is that I'm 100% sure that update has been called when late update is called, and that means that when our cube moves around in update, I'm sure that I don't move my sprite towards the position before the cube's position has been updated. If I would do it in update, the sprite's update might be called before the cube's update, because we have no way of telling which update is called first. So when you have to move an object after another object, for example a camera that follows another object or something, then you have to use late update. It's very simple what I'm going to do here. I'm just gonna set my position, so my transform dot position, because this script is attached to my sprite. Actually I'm gonna do transform dot local position, and that's equal to new vector 3, and here it wants x, y, and z position, and that's the target's local position dot z, oh sorry, x, and target dot local position dot y, and target dot local position dot z. Actually, sorry for confusing, but I don't want to use the y position of the target, because then it's going to jump to the cube. I actually want to use my own y position, so I'm just going to write transform dot local position dot y. So just to be clear here I'm using the cube's x position, and I'm using the cube's z position to position myself in the world, but I want to keep my own y position, so just write transform dot local position dot y here, so that you don't jump down underneath the what's called the surface of the 2D world. I would also like to be able to position myself correctly on the z axis, so actually I'm gonna make a public float here called z offset. Oh, it's a float like this, and I'm just gonna add it here. Okay, remember to save your script and go back into Unity. Click on the sprite here, you can see that we have a z offset and we have a target transform, and the target transform, it's just the agent here you can drag into your sprite object script. The 2D world, the sprite is under the 2D world, so just drag it into the 2D world so we know where it belongs to. So if you play your game now, the sprite should jump down, as you can see here, because it jumps to the cube's current position. But we want to add the offset a little, so if I write 0.5 or something, I want a little more, 0.8, that's too much, 0.6, yeah. For my sprite size, 0.6 looks fine for me. So I'm just going to stop my game again and write 0.6, so it follows the cube around with the offset of 0.6. If we run our game again and click anywhere on the world here, you can see that the character follows the cube around as if he was walking around the world. The only thing here is that we still need to face him in the right direction and play the right animations. But for now you can see that we have a 2D character walking around the game world with pathfinding. So now we actually just need to add the last animations and script it. First thing we might do is to add the last animations. So we need to add these walk east, west, north and south. We already have the east version, so this is going to be walk north, and that goes from 0 to 0 to 8. So we just drag it, put it up here, right? Walk north. After that we have walk west, and that goes from, as you can see, 9 to until 17. So we select these, pull them into, oops, sorry, I misclicked, 9 to 17, just drag them up here, walk west, and then we have from 18 to 26, that was walk south, and there you have it. Now we have all our animations. All the animations are here, and it created one more animation controller for each animation, but we actually only need one animation controller, so you might as well just delete these, because we already have the animation controller attached to our game object. So we select these animations and pull them into the animations, what's called animations folder, like this. So we have all our animations in here. These new game objects you might as well delete, because we don't need them. We only need our sprite here to switch between the animations. Okay, so if we click our animation controller and go to the Animator view, we need to add the rest of the animations. Drag them into the view like this. There we go. So we have walk east, walk north, walk south, and walk west. But we also want our characters to be able to idle. So if we go to the sprites and open the Professor Walk, we want him to be able to idle in all directions. And to do that, we can simply use two sprites of the same animation and then just loop them. So we need to copy this sprite sheet to be able to get two of the same sprites. So if we click this sprite sheet here and press Ctrl D, then you have two sprite sheets, and then you can click one of them. Let's take walk north. We do this. So this one is going to be idle north if we select the first one from the first sprite sheet and the first one from the second sprite sheet. Just pull it up here and call it idle north, and then we do the same for all the other directions. So we have one that's going to be idle west here, that's number 9 here, and let's take south, that's number 18, yeah, number 18 from both. Oh, sorry, idle south, of course. And then we need idle east, which should be number 27 from both. So what we just did was to create all the idle animations. So delete all the new game objects and minimize this. When we've done that, we might as well make some orders. So just delete the new animation controllers because we don't need them, and then move all the new animations into the animations folder, so we have everything put together here. What we have to do now is to add the new animations to the control as well. So idle east, idle north, idle south, and idle west. So now we need to make some functionality so that we can transition between these different states. And to do that, we need to make transitions between them, and we need a parameter to trigger these transitions. The parameter is made by clicking the plus button and selecting an integer, because we only want to react on a whole number. So we call this integer direction. And now we can start adding our functionality here of how these transitions should happen according to the direction parameter. And then later we can add a script that tells us what to do and when to do it. To accomplish this, we need to assign a value to each direction. If you look at the image here, you'll see that north has been assigned 1, south is assigned to 2, east is assigned to 3, and west is assigned to 4. That means that whenever this direction parameter is 1, we will start walking north. If it's 2, we'll start walking south, and 3 will start walking east, and 4 will start walking west. So to accomplish this, we need to add some transitions between these different states. So if we click on our north state, right click and say make transition to the west state. So if we're walking north and we certainly need to walk west, our transition needs to change the value, be triggered by the value of direction. It means that we can go to our conditions here and click direction and say, well, if our direction equals 4, so that means that if we are playing in the north animation and our direction suddenly equals 4, well then we should start walking west instead. Same goes for the other directions. If we're walking north and we start walking east, well then our direction should suddenly be triggered by 3. If we walk north and the transition suddenly should be triggered, then we need to trigger it on 2, because if the direction changes to 2, then we should start walking south. Same goes for all the other directions. We need to make transition back and forth. So from west to north, of course, from west to east, from west to south. Direction set to 2. Direction set to 3. Same goes from south. If direction changes to 1 when we're walking south, then we're going to walk north. If the direction changes to 4 when we're walking south, then we're going to walk west. And if it changes to 3 when we're walking south, then we are going to walk east. And we need the last one. We need to make the transition to north. South is 2. And west is 4. So now we have set up all our direction changes between the different directions. So we know when we're walking east that if the parameter changes to 1, we go north. If we change to 2, we go south. If it changes to 4, we go to the west, and so on. We also need to be able to react on the different idle states, because we need to figure out if we should idle. We can only go in an idle direction if we're walking to that side. That means if we're walking north, we should only be able to idle north. So we can easily make a transition here and say that if our direction equals 0, then we should start idling north. If we're walking west and our direction is 0 suddenly, then we should start idling west. And the same goes for south. So we also need to transition back from our idle states into our walking states. We don't need to be able to walk west when we're idling north, because we will just transition back to the north walking here, and then the north walking would automatically transition to the correct walking state. So if I made a transition back from idle north, and that's if direction is not equal to 0, which means that my direction is anything else than 0, it will transition back to north. Let's say that we're idling north and the direction suddenly becomes 2. Then it would go back to walk north and directly to walk south. The same goes for all the other directions if it's not equal to 0. Yeah, so now we have set up our tree so that we can transition between all these different states. So the only thing we need to do now is to create our script that changes this direction variable here so that we can transition. To be able to transition between the states, we need to have access to the Animator component on the Sprite game object. To do that, we need to reopen our script and create a variable that holds a Animator component. And we just call that Animator. Then we need to fetch the Animator component on the game object, so we just write get component. And then we take the Animator component. So this works exactly the same way as it does with the NavMesh agent. So we actually just fetch the component that sits on the sprite object here. When we've done that, we need to react on the different directions the sprite can walk. If we look at the agent game object here, you see that we have this NavMesh agent component on it, and this NavMesh agent component has a velocity, and this velocity is what we're going to use to react on the sprite animations. So if the velocity on the x-axis is bigger than 1, for example, we know that we are moving in the positive direction on the x-axis. If the y-axis is larger than 1, then we know that we are moving up on the y-axis. So to do that, we also need to be able to access this NavMesh agent component on the agent we are following. If we go back into our script, we can start writing the code that reacts on the velocity of the agent. So we can write myAgent.velocity to get the velocity of an agent. And this we need to do inside some if statement. So if myAgent.velocity.x equals 0, then we know that we are not moving in any direction on the x-axis, and we need to go into the idle state. And the idle state is set whenever the direction is 0. So if we say Animator.set integer, because the parameter is of the type integer, and we open up the parentheses and say direction, then we can assign the value of direction to 0. This means that whenever our agent isn't moving, we'll start idling. Then we have to look at all the other directions. So if we make an else if statement, then we can say if myAgent.velocity.c is greater than 0.5, then we know that we're going positively on the z-axis. This means that we're going up, which is north in this case. So we will set Animator.set integer.direction to 1, because north was assigned to 1. Then we have to make the opposite one. So if our c value is less than 0.5, then we want to go south, which is 2. Then we also have to look at the x-axis. So if our value x is greater than 0.5, then we need to go to the right, which is east. So that's the value of 3. And then we basically need to do the same down here, where we just turn this one less than. And if our x velocity is less than 0.5, then our direction needs to be 4. So now we set up everything so that our character should move in the right direction. Just going to check all of these so that all my transitions fit. And I can see that I forgot to assign the walk west, walk north. When I walk from west to north, that transition should only happen whenever my my direction changes to 1. And here I only have an exit time, so I need to set the direction to 1. So before you run this, just check that everything fits here with these directions. So if I run my game now, should be able to see that my character moves correctly around the world according to where it's it's going, it also applies the right animation. And as you can see up here in our animation controller, that if I walk to the right, it plays the walk east animation. If I walk to left, it plays the walk west animation and starts idling in the right position. If I go up here, it should play up, and then it should start idling north. And I can click wherever I want to on this map, and the character should move and navigate through the right path. And there you have it. That's how you can create a NavMesh and use it on a 2D animation character. All assets used in this video are available in the description below. Please don't forget to subscribe and visit inscopestudios.com for more programming training.